Understanding organic reactions. Before I begin, I would like to really emphasize the importance of this chapter. Yeah, I know you might have heard me say, oh, this chapter is very important, etc., etc. But this chapter, in addition to the second chapter, acids and bases, are so far the most important chapters. This chapter right here is going to teach you how to interpret, draw, and apply organic reactions till the rest of the year if you are going to take organic chemistry too. In addition, it will show you how organic chemists and essentially biochemists, pharmacology, etc., interpret what we call a reaction mechanism, which is the steps that are used to, again, elucidate what happens in a chemical reaction. We are no longer going to be satisfied with just the chemical equation like you learned in general chemistry, but we are now going to be interested in understanding those steps that occurred in between. Yes, there are reactions that occur in one step, but the majority or a lot of reactions occur in multiple steps. And this enables us to do tremendous things in terms of drug design and production. So invest time in this chapter, and I really mean it, and I hope you take my words seriously. So once you're done with this lecture, you should attempt the homework right away. It's okay to struggle at first. There's no easy way around it. You just have to dig in after reading this or viewing these videos and taking notes and starting to see how to apply the arrow pushing and mechanisms, reaction mechanisms. So let's start. So we'll begin with writing organic reactions. So it's a similar process to general chemistry equations. There are, of course, some differences. So here's an organic reaction. You have this organic reaction that involves the cyclohexane ring with a double bond and bromine. The one thing to tell you is that we have names for what's on the left and what's on the right. So, of course, we'll begin with what you're familiar with. These would be the product, or this would be the product. This right here, while we can use technically the names reactants, the words reactants, we like to call this right here the starting material. And this one right here, bromine, okay, we will call the reagent. So the reagent is what causes, right, the reaction or this transformation on the starting material. So there's no reaction, obviously, with that reagent or the starting material. So we call it the starting material and the reagent. Or it can be written another way. I'm going to show you in a second. The reagents can be drawn either to the left, like I said here, this is called the starting material, or above the reaction arrow to focus on the organic transformation taking place. So this is the focus right here. This is the overall transformation on the right. Right here. Now, solvent and temperature may be added above or below the arrow right here. The symbols H nu means light and delta means heat. So again, this is H nu and this is delta. Of course, byproducts are often omitted. They're not included. We're only interested in the main product. So this can be written this way, by the way. Right here, you put the reagent, and of course, you have the overall transformation. So here's another reaction. As I was telling you, it's a bit different than this one. So don't worry about the outcome for now. That's what we're going to do in this class. We have now cyclohexane, and of course we have bromine, but we can use H nu. It looks like a V, but this means light, or delta, which is heat. And of course, CCl4, which is our solvent. So let me mark this for you. This is light. This is heat. And this is the solvent. So you notice how all this information is included above and below the arrow. And you get, of course, this transformation. Now, this is what I mean by the byproduct. This right here is the byproduct, or the side product. Usually it's omitted, it's not included. There's another way of drawing a reaction. And that's when you have two or more sequential reactions or steps carried out without drawing the intermediate. So the middle part is not drawn. And what we do is we just focus again on the overall transformation. So if you look at this reaction right here, you notice that you have a starting material right here. And then you have steps. This is step 1 and that's step 2. So we're going to say this is step 1. And we're going to say this is step 2. And of course, again, this would be our product. There's a side product or byproduct that is not shown. Often they are left out because we're interested in the main or the overall transformation. So this is our overall transformation. So again, know what the numbers mean. Of course, there's no really convention on how actually things are put on the arrows right here. You could actually have, like let's say 2 steps above, you can have them 1 above and 1 below. Really, there isn't much of a uniformity in terms of how those reagents are, and especially the reagents are assigned on the arrows. But usually they follow something like this or like this. Very well. So there are types of reactions. I am not going to go over them now. So they're just for you to kind of develop a prior knowledge before we get to chapter 7, of course 8, and then 10 to 12. We're going to, after this chapter, start with organic reactions. Organic reactions are what we're going to do for the rest of the year. After this, that's it. We're kind of done with the basic theories. There will be theories, of course, in every chapter, but they will be, again, based on reactions and mechanisms. That's what organic chemistry is about. So there's a substitution. Z substitutes, or is actually leaves, and then Y replaces it. Like I said, just kind of look at them. We will examine them more fully in their respective chapters. That I think makes more sense rather than just overwhelm you right now. So just kind of look at it, and then for each chapter we will cover that.